Yeah, okay. Thank you so much. So potential of Q1. See, listen. Suppose there is, listen here, man. No. See here. This is Q1 whose influence is up to certain extent. Okay. Now, when I brought Q1 at a distance R1 from the origin, its influence is up to certain extent like this. Okay, its influence is up to certain extent. Now I have brought Q1 from infinity to this point under the influence of Q1. See, once again, see here. The work done required is nothing here for Q1. The work done is 0. Work done in bringing, see, work done in bringing Q1 from infinity, in bringing Q1 from infinity to point P, infinity to R1. Infinity to R1 is what? That is 0, because no work done is required. Now, but the potential is given here. Similarly, I want to bring the Q2 from infinity to a point under the influence of charge Q1. So you need some extra work done. What is the extra work done? So I'm writing here work done to move Q2 in the presence of Q1 is given by what? E is equal to W is equal to V1 into Q. W is equal to V1 into Q. So W is equal to what? V1 is 1 by 4 pi epsilon 0 into Q1 by R1 into Q. R1. The distance here is R1. So the work done is equal to what? Q1 Q2 by 4 pi epsilon 0 R2 R1. So this we can write as energy. U is equal to work done and energy are having the same dimensions. Work done and energy are having the same dimensions. So the energy is how much? Q1 Q2 by 4 pi epsilon 0 R1. Again from the beginning. Listen. Again from the beginning. See here. From the beginning. See here. Potential energy.
Sorry, one thing I wanted to say. It's fine. I'll tell later.
Potential energy of system of charges. See here. We have charges Q1, Q2 up to Qn. We have position vectors also. What is a position vector? A vector joining the origin to the point P is said to be the position vector. So we have R1 is the position vector for Q1. R2 is the position vector for Q2. And the distance between R12 is Q1, Q2 is R12. Now, is R12.
Why is there a circular?
Circular because that is the potential or region around which the electric field lies.
Oh.
Q1 has an influence up to some extent. Q1 is having an influence up to certain extent. Is that clear? Is it not? Now, now that is Q1. Now, I am going to bring, so the potential of this is how much? V1 is equal to 1 by 4 pi epsilon 0 Q by R1. The work done in bringing Q1 from infinity to this point is 0. You don't require any work done just because there is no force, no external force. But now I am going to bring Q2 from infinity to under the influence of this Q1. I am going to bring Q2 from infinity to under the influence of Q1. I have to do some work. So work done to move Q1 in the presence of Q1, that is Q2 in the presence of Q1, is how much? W is equal to V1 Q2. What is W? 1 by 4 pi epsilon 0 Q1 Q2 by R12. Why R12? This is the distance. So when you simplify, you get this formula. So instead of writing W, I'm writing U. Why? U is the potential energy. Okay. Here U is potential energy. Potential energy and work done are having the same dimensions. Both are measured in what?
Joules.
Joules or newtons?
Newtons.
Yes. Yes, Ismail, Dhruti and Moksha. Energy is measured in what? Is
joules.
Joules, pascals, newtons.
Joules.
Yeah.
Joules.
Joules. Very good. So that is why we are using them. Now I want to bring 3 charges. Now I want to bring next charge. What is that? I want to bring Q3 under the influence of, maybe I want to bring Q3 now. Q3 under the influence of. Now I want to bring Q3 under the influence of Q3 under the influence of Q2 and Q. Now when I want to bring Q3 under the influence of Q1, under the influence of Q1, it will be how much now? So we have work done to move a charge from infinity under the influence of Q1 and Q2 under the influence of Q1, Q2. Okay, so in that case, what will happen now? The potential energy is what? The potential energy is Q3 into V12. So we have Q3 into V12. This is U12 or we will write. This is U12. So here it will be how much now? Q3 into what is V12? V12 is equal to Q1, Q2 by R13. Q1, Q3 by R13. Q1, Q3 by R13. Here I write here 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0 into plus Q1, Q2 by Q2, Q3 by R13. R23. Is it clear? See here, we have Q1, Q3 by R13, Q2, Q3 by R23. That's a pass.
Not me.
Now, okay. The total work done will be how much now? The total here, the total work done will be is equal to how much? U is equal to 1 by 4 pi epsilon 0 into Q1, Q2 by R12 plus Q2, Q3 by R13, R23 plus Q1, Q3 by R13. Clear? So this is the formula. Once again, see, up to here we know. Now I want to bring Q3 under the influence of these two fellows. Then at that time, what will happen? I have to take 1 by 4 pi epsilon 0, Q1, Q3 by R13, Q2, Q3 by R13. Now add the total value because we have Q1, Q2 already it was there before. So I'm adding Q1, Q2 by R12 before value. So I get the total value like this. Okay, they can ask a numerical on this or on this. Is it clear all of you?
Yes, sir.
Now this is
Yes, sir.
this is without the external field. There is no external field now. Now we will be bringing the external field now. The same thing situation is brought under the external field now. This is without external field. Clear?
Yeah, sir.
Please copy this. See, potential energy is the characteristic of the present state of configuration and not the way how it was achieved. Keep this in mind. They can ask this question in assertion reasoning or maybe MCQ. Potential energy is the characteristic of the present state of configuration and not the way how it was brought. The configuration, see, where Q1, Q2, Q3 is kept together. Means what happens? See, we have different types of energy. In mechanical energy classification, we have potential energy, kinetic energy. Potential energy again classified into two: gravitational potential energy, elastic potential energy. Gravitational potential energy means suppose if you hold a stone like this and release it, it can do some work. And elastic potential energy means you have to hold a cord and arrow. What is it? Bow and arrow. If you stretch the bow and keep the arrow in that, okay, if you see Bahubali, you will have an idea for that. So if you stretch the bow and release it, what will happen? The energy which is stored in the bow will go to the arrow. So that is about, elastic potential energy. Kinetic energy means the energy due to the energy possessed by the body due to the motion of the body when it has certain velocity. Now, elastic potential energy or electrostatic potential energy means when you keep so many charges at one point, it can do some work. That is the situation happens in the battery. In the battery, or when we charge the battery, what is happening? When we charge the battery, what is happening? It's not like adding charges. All the charges are brought close to each other. You got my point? The charges are there already in the battery. The charges won't go away. Charges are there in the battery, but the charges are away from each other. By what we are doing while charging, when we are charging, what is happening? The charges are brought close to each other. When they are brought close to each other, what happens? They can do a lot of work. Understood? That is how the charging, there is a
Yes, sir.
charging. Got it? So that means when we charge a battery, it's nothing but we are increasing the potential energy of the battery in simple words, or potential energy of the charges. So when you bring so many charges together,
phone, it's like that.
It's like that. All the charges are brought together, very close to each other. 100% means almost all. That's a maximum you can do. Charges you have brought close to each other.
So as our battery reduces, that
means as they are moving away, that means what? It is losing the charge. Understood? The same thing happens. The old alarm pieces. We used to have a key on the backside.
12.
If you have seen that type of clocks, like on the backside, we will having key. So there will be like that key will be like what happens. This will be like a loop like this. What we will do is while we give the key, these loops will come closer and closer like this. Okay, these loops will become closer and closer like this. The more they come closer, they can release energy. When they go away from each other, they release a lot of energy, and the alarm starts working. That is what happens in, in the potential energy passing. Clear? Is it
Yes,
clear?
sir.
Yes.
Okay. So for today we will stop here. So tomorrow I'll be starting with external field. External field one is there, and electrostatics of a conductor is there, so that we can complete and start with conductors. Okay, capacitors.